Bismillahirrahmanirrahim. Theory of automata ki manga topic chide aga finite automata satoy. Finite automata chida pai ki awal khabar mung saradari chif automata satoy. Now automata is the plural of Greek word automation, which means something that work automatically. हर हाँ गशे हर वो चीज़ जो ऑटोमेटिकली काम करती हो उसे हम ऑटोमेटा कहते हैं। फाइनाइट ऑटोमेटा अब क्या है? फाइनाइट ऑटोमेटा में दो वर्ड्स हैं, एक है फाइनाइट, दूसरा है ऑटोमेटा। तो फाइनाइट का मतलब ये है कि इसमें नंबर ऑफ स्टेट्स फाइनाइट होंगे, नंबर ऑफ स्टेट्स क्या होंगे? फाइनाइट होंगे। और द लेटर्स आर बोथ फाइनाइट, स्टेट्स एंड लेटर्स आर बोथ फाइनाइट। इनमें जितनी भी स्टेट्स होंगी, जितनी भी लेटर्स होंगी, दोनों फाइनाइट होंगे। ऑटोमेटा का क्या मतलब है? ऑटोमेटा का मतलब ये है कि द चेंज ऑफ स्टेट इज़ टोटली गवर्न बाय द इनपुट, कि इसमें जो एक स्टेट से दूसरी स्टेट जब मूव करती है, ट्रांजैक्शन होती है, तो इसको इनपुट गवर्न करेगा, उन इनपुट मैनेज करेगा। इट इज़ नॉट गवर्न बाय द यूज़र, यूज़र इसे मैनेज नहीं करेगा। जैसी इसके पास जैसी ही इनपुट होगी, इसके मुताबिक ये स्टेट चेंज करेगा। A finite automata is a language recognizer. It recognize a language या token recognizer, a language of words ending with a. It means it contain words that must end with a. So each words in the language is a token. So it is a token recognizer finite automata, or it is a language recognizer. So regular expression is a language specifier or language generator. Regular expressions आप यहाँ पर दें कि सपोज लैंग्वेज, सपोज हम suppose a language of words ending with a. Ending with a means a is ending with a is also ending with a, a is also ending with a, a also ending with a, and so on. So ending with a is a language, ending with a infinite language. So a finite automata recognize this language. If we create a finite automata for this language, then we take each token and apply it on a finite automata. If this finite automata recognize this token, it means it belongs to this language ending with a. Then we take this one, apply to a finite automata. If the finite automata recognize, it means that the a belongs to the language ending with a. And if you see the regular expression, a regular expression a regular expression is a language generator. Suppose a plus b whole steric or multiplied by a. It means a language of words containing any combination of a, b at the beginning, but and must be a. So it generate language. It is a language of words ending with a, comma, ba, and so on. So it is a language generator and finite automata a recognizer. It is a recognizer of the language. Now, finite automata has two types. One is deterministic finite automata or simple finite automata. Second one is non-deterministic finite automata. Now, in this lecture, we are going to discuss what is mean by finite automata. Finite automata, recursive definition of finite automata consists of three things. The first one is finite set of states, finite set of transaction, alphabets. So that is a collection of three things. Finite set of states, it means that it consists of finite set of states. Suppose q0 is the initial state, q0 is the initial state, then Q1 and Q3 is the final states. It consists of one initial state. May a final states mean many final states. An intermediate state. In Q2 is the intermediate states. And this is whole a finite automata. The set of transactions from Q0, from state Q0 to Q1, it goes through input A. So the change of state is governed by the input A, and from Q0 to QA it is a transaction. From Q0 to Q2 on input letter B. So Q0 to Q1 is another transactions, and number of alphabets is A comma B. If we explain it in here, so it is Q0 on input A, it goes to Q1. So it is a transaction in which Q0 is the initial state, Q1 is the final state, and through input letter A. So it is a transactions. Now, our next transaction is from Q0 through input B. It goes to Q2. So it is another type of transaction. Now, what is the number of alphabets? Number of alphabets in that finite automata is A comma B. A comma B is the alphabet. So finite automata is also called finite acceptor because it accepts some string and rejects others. Now this is the example of finite automata. Finite automata is a set of five tuples. The first one is Q. Q is the set of state. Set of state. If it is a finite, it is a finite automata in which Q0, Q1, Q2, and Q3 are set of state. Capital sigma mean alphabets. Alphabets here is A comma B. A comma B is a set of alphabets. Transactions from Q0 to Q1 it through input letter A. It goes through input letter A from Q0 to Q1. So it is a transaction from Q0 to Q1, Q0 to Q2, Q2 to Q3, and so on. This is a set of transaction. Set S is the set of initial state. Q0 is the initial state. It must be one unique. And F is the final state. F is the final state. And here Q1 and Q3 are final states. Then in the next slide we show you that the Q is the set of state Q0, Q0, 1, 2, and 3, and set of alphabets is A comma B. Set of initial state is Q1, final state is Q1, and Q3 is a final state. Transaction from Q0 on input letter A, it goes to Q1. From Q0 on input letter A, it goes to Q1. The second one is from Q0 on input letter B, it goes to Q2. The third one is on Q when you are standing at Q1. On Q1 uh, on input letter A comma B, it goes to Q3. So if you are standing at Q2, on Q2 on input letter A, it goes to Q2. Therefore on Q2 on input letter A, it goes to Q3. uh, as well as when you standing at Q3, in input letter A comma B, it goes to Q3. So this is the definitions in introduction to the finite automata. Next we will move on to the representation of finite automata and how it recognize a language.